joining us today. I'm Medani Makulalua, and I'm delighted to be your host for the third session of Sri Lanka AI Challenge 2025. Today, we dive into one of the most exciting topics in the AI landscape, architecting scalable and secure AI agents. Before we begin, I would like to request all of you to update your display name in the given format. To power this session, we are honored to have an inspiring panel of experts with us. Mr. Purnima Kahatapitiya, Senior Software Engineer at Sysco LABS, Mr. Yasinda Samarnayaka, Senior Data Scientist at Sysco LABS, Mr. Janidhu Ratnayaka, Software Engineer at Sysco LABS, who will guide us on how to design AI agents that are not just powerful, but also secure and scalable. Mr. Purnima, Yasinda, and Janidhu, welcome. The virtual floor is yours.
Thank you, Medani, for that wonderful introduction. So let me introduce myself and our team. So I'm currently working as a senior software engineer at Cisco. So our team is called EAG. We are a small team. We are a team of 8 engineers and a couple of interns. But we do large scale projects. So we act as an incubation team. What we do is whenever there's new technology, new landscapes coming out, we do the R&D, we do the enterprise level development, and we incubate it into existing enterprise applications that are within Cisco. So right now, because the big talk is on generative AI, what we are doing is mainly spanning across generative AI projects. So talking about the journey coming towards generative AI, so we started back when OpenAI introduced their first model, and now we've evolved into building a no-code platform within Cisco, so that different teams can configure their own AI agents in an enterprise level. Using this platform is called the Cisco Agentic Ecosystem, and using this platform, we've been able to deploy and host multiple enterprise level AI related projects. Some of those projects are helping our sales consultants, helping our DevOps engineers, then helping our Cisco internal business services, and there are many use cases around it. So it's generating value. And to introduce the team, so we have Janidhu and Yasinda also with us. Incubation and R&D is just one part. We do tech marketing and tech evangelism as well. So this whole session is a part of that. So we want to show our experiences and share our experiences and how we can develop AI agents on an enterprise level. So I'll hand over the proceedings to Yasinda so that he can start off.
Yep, thanks, Purnima. Let me share the screen. Let me know if you guys can see the screen. Then I could get started. Which screen can you guys see?
Oh, we can see the presentation.
Okay, it's not the one with the Zoom app, right? Okay, let's get this up here. Yeah, so as Purnima explained pretty well, that we are a small team, but then we work from basically getting the use case upfront all the way till production, till we ensure that we're generating value. And it's a process that's easier said than done. Obviously, the start goes strong, and then once you reach the end where you're pushing things into prod and you're getting like thousands of users using your systems, that's where the real challenge is. So what we're trying to get out of today is to sort of guide you guys through that path. And yeah, that's exactly what we're trying to do. Hopefully you guys gain something out of this. And yeah, so I'll jump right into this. So before I begin, just to gauge where everyone is, what do you guys know about agentic AI? What does that mean to you? going to be that type of call. Just roughly, what do you guys know about it? Yeah. I don't see chats either. Cool. I'm just going to get onto it. So the main difference between traditional AI and agentic AI is that with traditional AI, you know the inputs you're providing. There's a set process, and therefore you get a set output. It's fixed. So you know what goes in, you know exactly what's going to happen in between, and then you get an output. So that's how traditional AI works. It's very much like an input process output thing. But the difference between agentic AI is a leap from that, because now what you have is you have a system that can perceive things, and based on that perception, it can plan and act, and then also sort of reflect to accomplish a common goal. And generally, this goal is a bit more complex than having an input, process, and then output. It is still a process, but that process now has reasoning. So because of that, it's not like you start with A and end with B. You could start with A and end with C, D, all the way to Z. So that's a little bit about what agentic AI is. And the reason so that's what agentic AI is. And the reason we need it is because right now, many of the systems we have are very coupled with human interactions, and then they're very brittle, they're very reactive. But what we want is something that's more proactive. We need something that we don't have to micromanage. So you know exactly what should be done, and you mention what should be done. And the reasoning, all that stuff happens within itself. So it's an end-to-end automation thing with very little supervision. But obviously, there are cases where you need humans in the loop and stuff like that. So that's why we need agentic AI. And I'll try to give an analogy from Pasindu. He's on this call, and this is his infamous example. So I'm going to go with that. So let's say you have a chef that specializes in just creating one thing, and that's dessert. That chef is really good at doing that particular thing. But what happens is when a customer wants something else, he or she might not be able to do that particular thing to how well another particular person who specializes in that one could do. So what you do, you get other people who are specialized in that particular thing. So now you have a set of chefs who are specialized in dessert, Indian food, Italian food, and Chinese food. But now what could happen is there could still be a chance where the customer requirement ends up with the wrong chef. You might be giving the chef who specializes in Indian food, a recipe for a dessert. And if that's the case, it's still not going to work out. So what you need is ideally a way to understand who could pick up that particular recipe the best, or that particular dish the best. So what you do is you bring in a head chef who can then get the requirement from the customer. They go through the menu, they see, okay, there's something I like. And then it goes to the head chef, who is not going to get involved with any of the cooking. That's going to be there to delegate the requirement from the customer to the particular chef. And that particular piece is what we call orchestration. So applying that analogy to agentic systems, you'll get something just like this. So you have an orchestrated agent who acts as the head chef, gets a requirement from the user. It could be like some sort of user query or some sort of prompt, right? And without getting involved in directly fulfilling that request, what they do is they route that user query to someone who could handle it better than themselves. So, one of the agents. So Purnima will get into detail on the different agents we have. So we have different types of agents, such as RAG agents, DB querying agents, API call agents, and then generic LLM agents. So I'll also go to a bit when we're going through the R&D section, but for now, just keep in mind that we have different types of agents who are controlled by the orchestrator, or more like routed in by the orchestrator. So like I said before, what we do as a team is we take something from a use case, a simple idea, all the way till the very end. That's the whole life cycle. Like I said, it's very easy to say, very hard to do. So that's exactly what we're trying to shed some light on today. So we feel like these particular things is how the journey generally goes. There's a lot of going back and then a lot of retrying in a particular tile. But more or less, this is exactly what happens. You get a use case, and then you sort of plan the architecture on how you can get this particular use case into the hands of the customers and therefore generate value. So after you do the planning and architecture, you get the implementation phase, which is arguably the most time-consuming / annoying part. So that's the implementation, and that further breaks down into 4 or 5 other stages. And after that comes deployment, that's essentially where you hand it over to the people who initially wanted this particular thing. And between all of these steps, you need to keep something in mind, and that's to always get feedback. So you don't wait till the very end to, sort of see whether the final full-fledged thing you've done is of use. So in between implementation to deployment, there's a lot of going back and forth and making sure that you actually have value. And to know whether you have a value is to evaluate something. So you push something into deployment, and every single iteration, you need to evaluate. You need to see whether this is fulfilling what the customers wanted, or if it's not, how can you, sort of go back and reiterate, come back out again some value. So that's why the early feedback thing is very important. And so those are the 5 key steps, but that's a very important 6th. This is not a 6, it's more like a 0. This is something that spans throughout the life cycle, and that's security, governance, and explainability, which is very important nowadays. And basically, explainable AI is to know how you got an output. You can't simply shove in a bunch of values, get something out, and then just sell it to the clients. If they ever wanted to debug, if they wanted to understand how they got something, you should be able to show them that. So that's a little bit about that. So I'll start off with use case identification. This is basically picking the right tool. So you get some requirement. Let's say the requirement is to look up and know the weather forecast for Mirissa tomorrow. If that's your requirement, you don't need an AI agent to do that. You could just do it with one API call. So it's important to understand what's your chainsaw and what's your butter knife. You don't need a chainsaw to cut a cake. You could, arguably, but it's going to be messy, and you really don't need that. So it's important to find that balance, understand what's needed, and if it doesn't need more than a single LLM call, then that's exactly what you should do. So that being said, we know what an agent is. We know when you should use it, and you also know exactly, you know when you should use it. And we hope you're here for the thing where you want to see how you build a agentic pipeline, because if not, the whole code is going to be really awkward. But yeah, for now, let's dive into what it takes to follow through that enterprise agentic lifecycle. And for that, I'll hand it over to Purnima to go through the architecture.
Yeah, thanks. Let me share my screen. Is it visible?
Yes, we can see it.
Yeah. So for the next few sections on this session, we are gonna have it more interactive and work ourselves through a use case, so that at the end of this, you would understand how to practically implement it rather than just going through some slides and understand like the theoretical aspects of implementation. You can see the use case, right?
Yes, Purnima, we can see it.
Yeah. So what we're trying to build here today is an AI-driven personal travel advisor. Basically like an travel assistant that can take like user questions like I'm planning a surfing trip in Sri Lanka on these dates, and my traveling budget is this. And then essentially what the AI agent should do is give like information out of like talk to existing weather APIs and get like the weather information. It can talk to like event APIs and take like local event information, and then exchange rate APIs, as well as Google search to get like real-time information. And based on that, what this travel buddy would do is give you like a plan, a detailed itinerary and a plan for you to plan your trip and assist in your traveling. So that's what we are trying to build today here. And for this, so this is basically like similar to in an enterprise system, in an enterprise ecosystem. This is how you basically get use cases. So business would come and say that we want this type of thing. So the first thing, like Yasin mentioned, you should understand if you need to bring a chainsaw to something that you don't want a chainsaw. First, you need to understand if this use case actually needs AI. And then the next like the hard phase is convincing business and people that, okay, this is not something you need to solve with AI. But if it's actually something that needs to be solved with AI, then we need to go into our next step and identify what type of AI we want. Is it going to be generative AI? Do we need to have like custom AI, like custom small language models, or do we need to have like a merge machine learning and data science with our generative AI? So those type of understandings and those type of information are required during this planning and architecture stage. So you would basically get your functional requirements, your NFRs, your non-functional requirements. You would get the same type of requirement list that you get like you're building a full stack application. But simply what would differ is the whole part where we need to identify which parts you need to use generative AI and which parts you don't need to use. So like I said, let's make this more interactive rather than just me going through a couple of slides and a couple of code. Maybe on the chat, if you can drop like some messages, what type of agents do you think we would require for this type of use case? So our use case is mainly to build a travel assistant. It will talk to real lifetime APIs, and then it needs to get some travel blogging information. So what type of agents do you think we would want in this? What type of? By this, Sasank, can we see the meeting chat, or like are they allowed to type on the meeting chat or no?
Yeah, they are allowed.
All right, cool. Before we go into it, I think it's hard for you to identify the AI agents. So like Yasin mentioned, I'll just give an introduction to what type of agents we have. So like on the first slide, we mentioned there are two types of main agents. One is called an orchestrate agent, then we have specialized agents. So what specialized agents do are they're specialized to do one function. It can be like getting information out of an API or like querying a DB or things like that. So we divide these specialized agents into several types. One is RAG. That is, I think in your previous session, you might have learned about RAG. That's a retrieval augmented generation agent. So what happens essentially here is you feed in knowledge because when we are talking to an LLM might have multiple information there. So you feed in specific knowledge that you want. There's a whole mechanism in how you feed in this specific knowledge and context. That's called this RAG, retrieval augmented generation. And then using those specific knowledge that you feed, you let the agent answer your questions. So that's RAG. Then we have API agent. So an API agent is simply talking to one of your APIs. But the special part here is so when we have different APIs, dynamic APIs, we need to build different payloads. And then the responses that come out of it, we need to filter. So if you're making it in a traditional approach, let's say you can simply call an API using like a function like HTTPX or something like that, right? But the difference here is you need to convert a user's natural language text into an API payload. And that API payload then needs to be called into your API. Then you get the response. And from that response, you need to again generate an humanized answer, like a natural language answer that a person would understand. So that whole flow is what's covered using an API agent. And then we have generic LLM agents. So what generic LLM agents do are they're basically like simply manipulating your LLM. So you can give your own prompts and you can pass in multimedia data. It can be just textual data or different multimedia data. And you give your own prompt and you manipulate the LLM to give an answer that you want. Then finally, we have DB agents. So what happens in DB agents is you can connect an AI agent with a database. Here, simply you pass in like the database schema, and then you pass in a couple of prompts. And what you do is you get the user question. From the user question, what you do is you build the particular for different DBs, like let's say it's a SQL DB, you build the SQL query, or if it's a MongoDB, you build the Mongo query. So you build the particular database queries out of natural language text based on the database schema. So like I said, each of these agents are specialized to one of their functions. And then we have a whole orchestrate agent. What it does is it will talk to these different agents, and it would it's like the HF. What it does is it identifies which agents it needs to talk to, and then get an aggregated answer out of all of these agents in a humanized way to the user. So now that you know what type of agents that are there, what type of agents do you think we would require for this use case? Okay,
I think it's that type of call.
Yeah, it's gonna be that type of call. All right, cool. Right. Okay, so I'll just assume what I'm saying is correct. But
Hey, we got one response from Praja.
all right, Praja says there's a weather API. That's good, right? All right, thanks, Praja, for that. All right, so when we are planning or when we are architecting one of these systems, basically our first step, what we would need to do is understand the features that are required. So on the functional requirements, we get like, on the previous use case, if you take a look at the use case, I think, Satsang, did you share the use case with them, or?
No, Purnima, I'll share the use case now.
All right, cool. So you'll see that there are requirements such as you need to advise and provide real-time insights on weather, advice on budgets, and things like that. And then it also says it's going to be a chat agent, a chat client. So when you consider about a chat, when you consider about a chat agent, what do you understand? So when there's a chat, there needs to be a conversation going on, right? So when there's a conversation going on, one of the main things you need to have is chat history and context awareness. So that's one of the features that we would require maintaining chat history and conversation history. Then another thing is, I don't know if you have used like ChatGPT and all. In ChatGPT, you can create these projects, right? I don't know if it's called projects now. Where you can give like background data, saying this is I am like a research assistant and I want this type of information. So whenever question is asked, give me based on research. So you set like a background context, right, for ChatGPT to answer. So that's another part of context awareness, where you give like background context and profile information. So maintaining like profiles and background information is another feature that we might have to worry about. Then another thing that it says is it needs to take like real-time weather predictions, like Praja said, and then it needs to talk to like currency exchange rates, get currency exchanges real time. So you need to give real-time insights as well, right? So that's another feature that we need to have. Then the whole part about recommendations coming, where you are creating like a travel itinerary and giving recommendations on what to wear, what to bring, where to go, and everything like that. And finally, like it says there's a part where you need to generate reports as well. So once we identify our features, then we go into our drawing board, and then we need to understand like, okay, these are features. Where are our integration points? So when I talk about integration points, let's take this in this landscape. Let's say we want to integrate it into this call, Zoom. So essentially, we'll need to integrate it with this meetings chat, right? Then we need to identify, okay, where is the user going to interact with this? It's going to be on this meetings chat. Okay. If they're going to interact with within this meetings chat, how are we going to integrate with it? So we'll have to get like a Zoom API to pass like chat responses, like to get chat responses and pass the pass information into this, right? So we'll need to have an API integration with Zoom. Then we understood that we need to get real-time insights out of weather and location and currency and a lot of things. So there are multiple external APIs that we need to talk to. So, and then the next thing we need, that this is a very important thing. So once we identify all of our integration points and everything, then comes into how we are going to deploy this and host this. So basically, if you have, like, let's say you want to build an agent, you can simply run like a function or a code on a notebook or something like that. But how are you going to like communicate with that agent? You need a way to communicate with that, right? Now, like I said, if you are going to integrate with this meetings chat, and if it's an API call, there needs to be an API integration, right? For that API integration, like let's talk about the protocols that supports API integration. So we have REST. Like it needs to be either HTTP or HTTPS call. So that means your agent that you're building needs to be built as a service that can be called through an API. So if your agent is going to be a service that you can call using an API, then you need to host this as well, right? So when you host this, when you're building an LLM agent, there are basically like you have your prompts and model configurations, and your basic AI agent configurations, like let's say your APIs, external APIs that you need to talk to, and everything that lies within the agent. And let's say that lies within your code, and you get this deployed and hosted, and now, okay, it's integrated with your chat. And okay, out of the sudden, one of these APIs, it goes, it's deprecated. Let's say the Open API thing that Madhusha said, Open with API, that's deprecated. And suddenly, okay, your production application is failing. Now you need to change it. How would you change it if it's in your code? You want to do a redeployment of your code, right? You need to change everything and redeploy. So giving a background story, when we were first developing this also, we came across this when we were developing AI agents. And what we understood is configurations for an agent, like prompts, models, and things, keeping them within the code, it's not going to be scalable and it's not going to be reusable. The best example I told you right now, if the API goes down, we'll have to wait for a redeployment, a code change, which might, I don't know how long that will take. But that means on a production level application, it's not working. So imagine this is like a financial agent that gives real-time insights on stock trading and the stock market trading. That 1 second would make you lose a lot of things, right? But what if there's a simple way where you can simply change that API and it'll still work in your production level application? So that's where we need to separate your configurations out from your code, keep it outside of it, so that you can simply change your configurations at any time, and it would reflect on your production level application. So it's important that when you're developing applications, your AI agents, you have your prompt, your AI configuration separated out from your code. So it doesn't matter, you can persist it within a DB, you can persist it as a JSON on like a bucket, or like keep it as a file. It doesn't matter how you keep it, but it needs to be separated out, and in a way you can simply change that configuration in real time. Maybe it's using an API call, maybe it's by uploading a new configuration, but it needs to be separated out. Then after we decide our integration points and how we are developing this, we need to identify what type of data sources that we require. So from what I understood from the use case, the first thing we would want to know is like information about, let's say we are building a travel agent to Sri Lanka. We need information about Sri Lanka, right? It might be from travel blogs, it might be from like books, PDF documents, it might be from websites. So this information needs to be provided to the agent, right? So when it comes to that kind of scenario, what I thought was we would need a RAG agent to have this static information out. And how we can add this static information is we can like scrape content out of a travel blog or like upload certain documents and have them in a vector store and have a RAG agent. Then we need to have a whole API agent to call these external APIs and get this information out. So there's an architectural decision there as well. Instances where you need to go with an API agent, and there might be instances where you can use a generic agent with a tool calling. So there's an option where on agent building called tool calling. So on an LLM, basically you can give like instances where you can define like a tool, like an API call tool, and you can give like a example instance where the LLM once a user question's intent matches with that certain intent of calling that tool, it could call that tool and get that information out and then add it into its context. So you can use an approach like that as well. And then another thing would be you would need a generic LLM agent to like summarize this information out and give a final answer. So then now that we've understood what type of agents we want, then, and like I said, since I said we have like tool calling, we need to then figure out what type of tools that are required. So one thing is, like I said, we have web scraping. So we need to build a tool for that. Yes. I don't know who Pixel 8 is, but Pixel 8, yes, we can call a RAG agent. We can use, so anything where there's a LLM, you can definitely call a tool. So a RAG agent can have a tool calling as well. So once we figure out that part, then comes in this whole part of the additional non-functional requirements there. So security is one thing, governance is another thing, explainable AI. Then there might be instances, let's say we are having financial data, if we need to mask this financial data before it goes to an LLM. And let's say we are accessing confidential information, when it is coming to the user, do we need to mask or anonymize this data? And certain things like if we are like automating workflows, like automatically booking like a hotel, do we need to have a human in the loop intervention where before the agent automatically books, the human approves it? So those kind of other external things also need to be considered when you're planning and architecting. So those are the things that comes with AI agent development, and then obviously choosing the right model comes in, like what type of LLM that you want to go with. I think Yasin would talk about it in depth in the R&D phase, but the rest is similar to a full stack application. So like I said, you need to communicate with this. So you need microservices or services. It can be microservices or just services. So how you develop this, it can be either fast API or it can be Spring Boot, what type of databases you want. If you're storing or persisting information in a database, does it need to be a SQL database? What type of vector stores, if you're having a right bot, is it going to be what type of vector stores that you need, Chroma, Pinecone, or like vector search? Then if you want to build your own chat interface and chat client, or like if you're integrating it with a front-end application, are you going to have front ends, like what type of technology you want to use there, where you are going to host these services, what type of cloud environment, is it going to be in Kubernetes, it's going to be in serverless, or is it going to be in AWS or GCP? Then how the continuous deployment and continuous integration works. Are you going to it can be your different pipelines. And then finally, once all of this is developed and put into production, then you need to have monitoring. So you can have different traces that you do. You can have log tracing, then you can have application performance monitoring, then you can have different types of monitoring there as well. And then the whole testing and evaluation part is also there that I've not added it here, but I think, sorry, did someone have a question? Yeah. Okay, so we are, Janit would talk about the evaluation part, but after we've done this planning phase and architectural phase, where this will come into a drawing board where you will draw a proper architecture. Then it goes into the whole R&D phase where you have to determine how to build your agents, what type of individual technologies you need to build these agents. And I think Yasinda would talk in depth on those things. All right, do we have any questions? Okay.
Okay, hold on. Let me just share the screen. Yeah, so that's basically so now you guys have an idea on how you can plan and also basically architect your approach. And based on that, obviously, once you do that, then only you actually get on with the code level, because it will be very counterintuitive to start the code first and then, sort of go back to fix the blueprints on how you created your end-to-end system. So what we'll do now is we'll take a look at that whole life cycle, specifically the second stage of the implementation, where you now get to the actual R&D. So let me just shut up here. If you guys can see the screen. See a notebook. A loop.
I can see this.
Cool. Thanks. Okay, so now that you know the use case, that's the one Purnima just shared with you guys. So then it's important to identify how you're going to structure that architecture you decided to map that into the actual workflow. So there's a bunch of decisions you need to make. So I think first thing, generally, at least what we do is we ignore the agents. What we think about first is where does the information lie to help the users with their particular queries. So like Purnima mentioned, there's some information about weather, there's some information about currency exchange. So those things, they're out there. It's a matter of understanding how we can ingest them. And then also, obviously, we're going to need blog information, brochure information about, let's say, for example, Colombo, Marissa, however you want to expand your agentic system to include more and more cities. So, and there's also decisions you need to make, such as what framework you're going to go with, what SDK you're going to use. So there's different options like LangChain, Llama, Crew, N8N, that's AutoGen, there's a lot. But even how you can construct your orchestrator, there's multiple permutations inside permutations. So it's important that you identify what's your use case, what you're trying to solve, and how you can derive value. So in this particular example, we'll be going ahead with LangChain along with Vertex AI for the SDK. So yeah, so like I mentioned before, we can identify the agents now because we need API. I've mentioned API agents because there's two. There's the weather API agent, and then there's also the API agent who can give us information about the currency. And then also we need a RAG agent to pull information from different documents that might have information from, web scrape from the internet or some stuff people directly uploaded. So that's exactly what we're going to do. We're going to start setting up these different agents. So something I want to emphasize is this particular stage we're on is the R&D. And you'll see that comparison from going to R&D into production and like modularizing everything. But let's not worry about that right now. For now, let's focus on how we're going to build this in a very, in the first scale, basically. So let's start up by importing the stuff. So I'm not going to spend too long on this. And I believe you guys already had the previous session on RAG and fine tuning. So I'll try to skim through all of this stuff. So generally, when you're making an enterprise level application, enterprise level agentic pipeline, which includes a RAG agent, you need to have a few steps. So you can't directly put in the user query. It's generally recommended that you optimize the query based on the context of what's important. Like, for example, if your system is to help customers know about a particular product, if they say something like where product, which is very vague, your query optimizer should be able to convert that into something like where is my product, and then you can fetch information about their IDs and then better support them. So that sort of thing is quite important, query optimizing. And so before I get into the rest, I'll quickly explain how RAG works. So basically, RAG is a way for you to understand. It's a way for you to have a bunch of information in text or images or videos, and then for you to ingest that information in a way that an LLM can use to have as context. So in our case, it'll be a bunch of travel documents from random people, and we scrape the internet, and then we take the text out of it, and then we convert them to a numerical format, and we ingest them into what's called a vector DB. So then when a user asks a question again, we do the same thing to the user question, where we convert that to a vector format, and then we perform a similarity search between what you already ingested and what the user just asked. And based on that, you can see how close of, for example, if someone asks, what can I do in Mirisa? You're now going to have certain embeddings that are mapping with what you just uploaded into your vector store. So you're going to find certain things like Mirisa, that's going to be, it's semantic. It's not like a one-to-one mapping. It's not a keyword search. It's a semantic search where it'll tell you everything it knows about Mirisa. And then that's used as context to support the user's query. So you create the embeddings, and then you perform the search. You get the chunks that are similar, pass that as context, and then you take the context that's used for support, humanize it, and then you give it back to the user. Things we also recommend are certain things like re-ranking. So that way, when you get the initial chunk of similar stuff, we can. Someone have a question? Okay. Yeah, so you can get the similar stuff based on what you scraped out of the internet. It's just to support the LLM better. You could always do a generic LLM call, but then not everything out there is something the LLM might know. If you ask the LLM about something that happened, if you ask ChatGPT something that happened today without the tool to do a web search, it won't know. So RAG is there for you to make sure it knows everything about what you want. It can be domain specific. Like, for example, in our case, things about our company, not everything might be out there. So we need to have a place that has that information we want in the highest integrity. So if it doesn't have, it says it doesn't have. But if it has, it'll let you know. So it won't hallucinate. That's a little bit about RAG. So what we'll do here is we'll first initialize the LLM. In our case, we're using Gemini Flash 001. And we also need to set up that embedding model, which is the one we're going to use to do the similarity later. So I'll just quickly go over what temperature, max output tokens, top P, seed, and all those stuff mean. So temperature, keeping it very basic, think of it as how creative you want the LLM output to be. If you want it to have something that's very consistent, reliable each time, then you want to have it decreased. The more you increase the temperature, if you're creating a story, for example, a storybook, you'd want it to have an amazing amount of imagination, right? So generally, and you probably don't want the same chapter repeating again and again. So then you'd increase the temperature. But if you want deterministic stuff that are more reliable, you go with a lower temperature. Max output tokens, it's exactly what it says. It's how many, it's what's the limit of the LLM that can, keep responding. So if it reaches more than 8,000, it won't give you the answer. It'll get truncated. And top P is basically, so the way LLM works is they keep predicting the next best word, next best token. So if you say the sky is blank, it'll have certain options like blue, purple, gloomy, red, stuff like that. But obviously red would have such a low probability. It won't get captured to this. So top P, in this case, it'll take a summation of the 90% of the next best tokens. So stuff like red, purple, they'll get canceled. So you'll probably have the gloomy and the blues. So then you initialize the embeddings. I'm just going to glance through this stuff. And then you create how you want to chunk your document. Like I said, you're going to scrape the internet. And you can't directly ingest it all as one document. It's better if you chunk it. So when you ask a question again, when you ask a user's query, it's easier to pull out all of the related chunks. You don't want to pull out the entire document. So you break it, and there's different ways in which you can chunk. But again, you guys probably did a session on this, so I'm just going to go over this. Yeah, then we create the prompts. On one thing is to understand, so we're going to have different prompts here, and there are different prompt engineering frameworks that I use. I'll explain a few later. There's different stuff like Ryzen, RaceF. We'll get to those later. So what we're going to do now is we're going to get some websites, and then we're going to scrape that. And then we're going to create the vector store. In my case, we're using FIS, a fast indexing, but obviously in Cisco, we don't go with this because it's not that scalable. We go with stuff like vector search from Google themselves. And yeah, so that's on that. Then we create the RAG chain, and then we obviously ask questions. And then some other methods I've included just to understand the health of our vector store. So I kept this stuff running already. So if you take a look at this, what we're doing now is we've initialized a RAG agent, and we're scraping information from different websites. And then you can see we're creating the vector store, creating the RAG chain. And now you can ask certain things like, where can I go whale watching in Verista? So I'll just show you what I extracted, different stuff like this. There's a bunch of random stuff. So even to scrape, there are multiple ways you could do it. Right now, I'm using Beautiful Soup. It's very straightforward, very static, very simple. But if you want to go for something which has AI-enabled scraping, where they crawl into all of these different, so like, for example, if you just point this URL, it'll scrape into each of these topics and then get that information out. There's great stuff like Crawl for AI. You could use if you want a better scraping experience. Yeah, so then you can ask stuff like, where can I go whale watching? And then what it'll do is it'll pull out the matching chunks, like the stuff we just broke down from the document. And then you put output based only on what it knows. Anything beyond that, it will not say. And that's exactly why most might think that's a downside of RAG, but that's actually very important that it doesn't hallucinate from what it doesn't know. That's something very common if you take LLMs like ChatGPT. Basically, any LLM can hallucinate, but with a RAG, it contains its knowledge, and you can be very sure that, well, arguable, but very likely that it's going to spit out from only what it knows. So yeah, and then obviously this is a very straightforward thing, but we can also try out something that's a bit more, it's like a needle in the haystack kind of question. So you can be like, what is a place where I can climb a rock and see a beautiful view? And then you could say something like Parrot Rock. And this was somewhere, Parrot Rock. Yeah, so this is the part where it said that. So that sort of stuff you can pick out. And that's just to show how specific you can get with RAG. And yeah, that's just about how RAG works. I'm not going to spend too much time on that. You guys already saw that. And then we have API agents. So again, in this, we have our way of doing it in the enterprise level, in which, well, it can't just be you hard code everything, right? You can't just give the API agent, you can't just give the API URL, just say what's the method you want, whether it's a post or a get. It needs to be a bit more robust. It needs to be more dynamic. For example, even if you are calling a currency API agent, you still need to know how to map that payload, right? You're calling an LLM, you're calling an API, and to do that, you need to map the payload, the header, and then you actually do the call. And that often requires authentication if it's an API that has a lot of information, or generally you need a key to do that sort of thing. So you need to consider authentication. And once you get the output from the API, some API responses could be huge, and that itself could take down the token size of your LLM. Very unlikely to happen nowadays because there's LLMs with around 2 million tokens. But it would be better to manipulate the response you just got. So what you can do is there's an injection layer you do in between. When you get the response, you can trim it out, manipulate it however you want, and then only does it get to that humanizing stage where you take the original JSON response, you get that into a format people can understand, and then you give it out. So in this case, like Purnima mentioned before, we'll be going with a currency API agent. So in that one, we have the initial payload prompt. So over here, we are defining the logic on if the user asks something like, look, I'm from Sri Lanka, I'm going to the UK, and I have 10 million LKR with me, would that be enough? So that's not a direct question you can shove into the API. You obviously need to handle it. You need to identify the right payload, and then only you can actually call the API. So that's the prompt. That's the logic you include here. So you need to help the LLM, right? So that's where you include that sort of thing. And then after you get that, you humanize it. That's another prompt we have here. So generate the payload, call the API, and then these are just stuff I have in case of a fallback, in case you can't get the ideal output. I'm just going to skip over that. So what would happen is you'll get something like this. So these are obviously very generic stuff you can ask, but based on how you structure your pipeline and the prompt specifically, you can get it to be a whole lot more natural in the way you can ask questions. It doesn't have to be a, USD 100 mapped to GBP, something like that. It doesn't have to be a very robotic thing. You can be very semantic about it. So for example, you could say, I have this, how much is that in USD? So now you're mapping that payload to get, so you're extracting the codes, like you mentioned in the prompt. You're extracting LKR from this, and then you're extracting that it should go to with the amount this. So it's important that you don't flip the whole to and from. That depends on how well you give your prompt. So then you would say, okay, this is what you want. But then you could also say certain things like I'm going from UK to Sri Lanka with this much. So now you don't state the LKR, but you want it to figure that out. So those kind of stuff can also easily happen. And yeah, that's just a little bit about the API agent. And then we have the weather agent. So the reason why this is the other agent Purnima mentioned about. So in this one, similarly, you'll have the payload mapping stage, humanizing stage. But in this case, you'll notice that we need to be a bit more cautious, because basically the more complicated the API can get, you need to handle that level of complication with extreme care, because it's not just you send the API, you get a response. You need to dynamically assign stuff. You need to populate stuff. So that hydration piece needs to be handled very carefully, because in this one, a good example is that this particular API, it handles something called weather type. And that could be whether it's the historic thing or whether it's a forecast. So if the user asks something like, what's the weather in Miris the day after tomorrow, obviously that particular field can't be set to current, because it should be for forecast, right? Tomorrow didn't happen yet. So it should be swapped to forecast. And obviously it needs to extract the dates. Users are not going to be like, what's the weather at 2025-06-18 for it to say 18th of June. They're not going to be like that. They want it to be very natural, just like how you and I speak. So you should be able to extract those dates too, and obviously the location. So just another quick thing to mention, a better fallback in this case would be to revert to something like NLP with name entity recognition. That way, even if for some reason, like Purnima mentioned, the LLM is down or it's unable to get you a response, you can always revert back to, the good old algorithm. But yeah, just a thought out there. But yeah, so you can call the API and you'll extract certain things from the payload you just created, which is the mapping stage. And then you'll include all the URLs you want to exhaust to try to get that information out. And headers, so sometimes even the headers you need to create dynamically. In this case, you don't have to. So as long as you get a response of 200, that means the payload you created worked with the API you're trying to. And if that's the case, we can go ahead with that. If not, you do a fallback. Yeah. Another thing that's important to keep in mind is when you're going to production, fallbacks are very important. And also stuff like retry mechanisms, they're really important. But Purnima will get into detail on this later. So let's quickly go through this fallback stuff. Yeah, and then you humanize it, and then that's it for the API agent. So how that would work in action, it would be, again, you can get very generic stuff like this, definitely answer. And then you can ask stuff like, how's the weather in Colombo today? So now you see the mapping. You need to extract Colombo. You need to say the country, but in this particular case, the API doesn't need that, because if you say Colombo, it will do a city search. But in case the API needs this particular thing, that should be something you handle in your prompt. And then in this case, date should be set to current because today is current. And then the weather type again should be current. So 3 things we hydrated just now. That's a very generic thing. But then you could also say weather in Tokyo for now you're giving dates, July 21st and 22nd. So you could take it one step above and then, have them not even say July, but then you're taking the assumption that they're talking about July. So it's always a trade-off. And before you build any system, you need to get feedback on what sort of thing you're potentially on the market for. And then based on that, you build your solution. So when you say weather in Tokyo for July 21st and 22nd, now you see we're extracting the dates. We're extracting 21st, 22nd. And then now this is the forecast. 21st and 22nd didn't happen yet. So again, the dynamic mapping part, very important. And that's how you construct an API agent. So we'll be sharing this notebook with you guys. So don't feel overwhelmed. You can always go back to it. This will probably be recorded. You can go back to it, take your time. If you have any questions, you can always reach out. And then we have the DB agent. This is something that's not important for this particular use case, but this is a very important agent because sometimes you'll have, obviously, it's called a database. You have data in it. And sometimes you need to query the DB to get the information from, whatever you have there, right? So the way this would work is, again, authentication, very important. And you need to provide the DB configs initially. So what would happen is, assuming you've set up the DB configs, and then you have a way to, in a safe manner, connect to it, then what needs to happen is when a user query comes in, you need to first be able to identify the tables you have in the particular schema. Like sometimes these can be joins, right? Like if this is something like what classes do I have, right? If it's a student asking this from, let's say, a university portal, when they say what classes do I have, you need to convert that have into identifying what the user ID is. And then you need to query the DB to see, you might have 2 tables, right? One for the students and then one for the mapping classes. So you need to construct an SQL query which can do that sort of left join and then give you that, construct that query, call the DB, get the results, then you humanize it. And if you can't find it, you need to be able to, your reasoning component should be able to identify that, okay, I tried this particular left join, I couldn't get a response. Maybe it's because I missed out this. So it's that way of learning. And that's exactly why agentic AI is different to traditional AI. Because traditional AI would try it once, give up, and then call it a day. But with agentic AI, it tries to reason. And that's exactly why it's that much more powerful. So yeah, and then last stage is obviously you get the response from the organic DB, then you humanize it. Same as, so you see that humanizing part and then the initial constructing stuff is a common thing throughout different agents. And okay, so now you created the RAG agent, you have the API agent, you know how, you don't know how to create a DB agent, but you get the gist of it. Then you need that head chef. You have this stuff standalone, but it's not good standalone. Like customers, in the case of the use case Purnima mentioned about the travel thing, they don't want to just know how much their rupees are worth in USD. They don't want to just know what's the weather. They want to see it all combined with information from the internet, how much they have and the days. You should be able to combine it, then give that information together. That's the head chef coming in. So again, this has so many permutations on how you can do the whole orchestration piece. You can have, you have centralized orchestrators, you have hierarchical ones, federated ones. There's a lot. And rather than me spending time on this, I think it's better if you guys go through, just research on that. But for this case, we'll be going with centralized orchestration with LLM-based routing. What that means is you're going to have one orchestrator who's able to talk to multiple specialized agents, those specialized chefs. And then the way it reasons, on identifying, okay, this is the agent I need for this particular user query, depends on that LLM-based routing. So I'll quickly go over that too. So what this orchestrator needs is the user query, obviously. It needs routing rules, and then it needs user query, the routing rules, and then obviously the prompts. So the routing rules essentially tells the orchestrator, hey, look, these are the agents you have in your toolkit, and this is when you should invoke them. So it's a very generic way to try to capture all of the different intents from the user. and then you say, if the user's intent is something like this, make sure to call this API agent because this person can help you with that. And sometimes it's not even just one execution. You can have multiple agents that can help you with something. And if that's the case, you should be able to invoke all of the different agents in sometimes even the order matters. So those kind of stuff, that's what the orchestrator does. It doesn't actually call it, but it knows what to call and how we can get that information to give a combined, probably the best answer from all of the stuff. So for this, we are using a Ryzen framework, which is what I said before. So prompt engineering is a big deal. It's about how you structure your prompt. It's as good as how you teach someone something. Obviously, you could be very close up about it, but they're not going to understand. But you could provide examples. You could tell exactly what the goal is, the steps to achieve that goal, and the right instructions. So I'll show how that is done. But just before that, I'll explain the sort of agent configuration, the routing rules we provide. So now we're essentially telling the orchestrator, look, these are the agents you have. You can tag in some ID. You can say stuff like you have a RAG agent. This guy can handle these sort of questions. And you can give keywords. You can give example questions. I think example questions are a bit better because that way the LLM is able to understand the semantics between the example you gave and what the user query actually asked. So it doesn't really matter as this is just LLM-based routing. Yeah. So these are the configuration rules on how you're going to tell LLM, these what you have in hand, figure out who you want to trigger based on the user's query. And then now we get to that actual prompt where you're helping the LLM understand what agents they need. So in this, we're following a Ryzen approach. Ryzen stands for role, instruction, steps, end goal, and narrowing. And basically, it's a way for you to try to ground the LLM in a way you can, sort of switch off the hyperparameters that are not important and to have it obey your instruction a bit better. So that's what we're saying here. So we are giving the instructions. You're going to be passing the agent info in as at hand, the routing rules, and then the steps, and then the end goals, and then the sort of output you want. So once you do this stage, it's just going to tell the orchestrator which agents it needs to call. And after that, once it picks out the agents, it's going to execute them either parallelly or sequentially, depends on your use case. If runtime is a big deal, you should always go with parallel execution. But in this case, we're just going with sequential. And you do the sequential calls for the different agents, the RAG agent, the API agent, and then you get the final response. Once you get the final response, it's going to be in different weird formats. Like the RAG would give you a chunk of text. The API would give you a JSON. That's not good enough to show to the user, so you obviously need to humanize that. And I'm just going to skip through all this. It's about how you register it, how you configure the orchestrator, stuff like that. Again, feel free to go through the notebook, raise any questions to us even after the sessions. That's completely fine. So let's go through, and this is what you'll get. So now I've created the instance for the orchestrator, and then I'm registering the agents we have. So this goes in the, even when you're doing R&D something, our team, what we like to do is keep the end goal in mind. True, it is still R&D, but there's a lot of time you're going to waste if you just build that first thing and then you later realize you need to do a whole architectural change. So it is a trade-off. Sometimes you need speed over having everything to be perfect. But if it's something you've done for a while, it's better to prepare yourself for the end integration points. That's something Purnima will also touch upon later. So yeah, so registering the agents, and then you have the routing rules. And then what you do is, so now you can actually ask questions because you've set it up, you add the routing rules, you've told it what sort of agents it has, and now you can just ask questions. So if you ask something like, I want to go to Marissa, what can I do there and what's the weather like? So now, if you notice, you don't need any sort of currency, right, to help this user with this particular thing. It's just, he or she just wants to go to Marissa and they want to know what the weather will be like. So in that case, you can see that it picked up the RAG and then the weather agent. And that's exactly what we want. We don't need currency for this. And if you do in production, it is a big deal if you have an agent that's not needed because runtime and also cost. So it's important that your LLM-based reasoning is able to pick up which agents are needed. So you do that thing, and it's going to retrieve for RAG, and it's going to get the weather from the weather API, and it's going to give you a combined thing saying, okay, cool, this is what you can do there, and then to use the weather. But then they can also get a bit more specific, right? They can be like, now just tell me what I can do there with the weather, and my budget's $1,000 for these particular days. It's a user that knows exactly what they want to do, which is very rare in the real world. Most of the time, you don't have people like this. But yeah, but you should be able to support that. And if you notice now, we are picking up the RAG agent, the weather agent, and also the currency agent. It just makes sense, right? Because the user wants to know about all that kind of stuff. And that's exactly what you do. You give out the answer. And you can also do certain things like, if I'm going to Malaysia on the 20th, 21st, and 22nd with a budget of this, what do you recommend I do there? So it's able to take in that budget, and then based on the stuff you've scraped from the internet, if it can support that answer, it will. If it can't, if the orchestrator can't answer that, it will just simply say it can't. So that's just a little bit on how the orchestrator is able to sort of pick on what's needed, create that execution plan, and then execute. So that's a little bit about that. So I'll hand it over to Purnima, but just before that, something really important here is, so this is the R&D, right? Most of the time, it's not going to be a perfect thing where your R&D can directly go into production. You need to move out of notebooks. And if you guys notice, I put a lot of exclamation marks here. Very important, because the moment you get out of notebooks and you build that modularized service, it makes everything easier. You can scale better. It's easier to debug certain things, and also easier when multiple people are working on it. So, and you also need to, even moving out of R&D, even though you haven't given it to the customers yet, it's important to evaluate that at this level even, and get the information, see what sort of value you're generating, right? And because even right now, if you could get to know, okay, these are not the agents I want, I need different tools. So then you can know it now itself before you throw it into the deployed version. And most of the time, like I said before, you need to handle sequential calls, parallel calls, whether they should be a sync thing and a sync thing, all that stuff. You'll get a lot more understanding once you move it into the service level. And structuring into the module, that's very important. You need to break this entire thing down into, the generic controllers, services, reports, that sort of thing. And obviously preparing for the deployment. So I'll leave that for Purnima. He's going to go through how you can get it production ready. And after that, Janti will highlight a lot more on that and give you what sort of evaluations and how security comes into all of this. Yep. Thank you.
All right. Thanks, Yasin. You want a break? Lot of
I want a break. I feel like I have nothing left inside my mouth right now.
All right. So I'll first now, like Yasin mentioned, the R&D phase is really important, because that's where, so I think our director.
Excuse me 1 second, Purnima. So if you guys want to keep a short break, we could go to the queue, go to some questions in the slider and then come back. So that's also, we could do that as well. But yeah.
Anything, do you think it'll break the flow? Anything that you all prefer. So while going on, I'll just answer some questions as well. So there's a question where can't we use MCP for an agent instead of an API agent? You can absolutely use an MCP agent, but the underlying concept behind an MCP client is similar to an API agent as well, right? So you basically have a bunch of functions that you wrap around the MCP server. And to talk to that MCP server, you need to use probably REST or some kind of protocol like that. So an API agent is a place where you integrate with, so you can definitely use, you can build your workflows as an MCP server, but to communicate with that, you'll need a tool calling or an API agent definitely to talk to it. So yeah, one question, that's one question. And then there's another part of how do I do CI/CD for my agentic AI app. So I'll cover that part with this session as well. So like I said, we don't host agents, we host agentic services. So when we host agentic services, the CI/CD is similar to you hosting a normal service. So I'll just walk you through that as well. So, but coming on to this, so basically for our use case, now that we've done our R&D and we've understood our agents, so why the R&D phase is important is that the initial cut. So when we try the initial cut, like there's a nice word RD like to say, fail fast. So I think getting something out and failing fast is really important in this landscape because you don't know what your end users expect, right? So maybe having that notebook and having someone try it out would make us understand if we are choosing the right agent, if we are choosing the right tools. Because after you build your service, and if you need to completely change your architecture, then it's going to waste your time because you need to host your service and all of that. So for our travel buddy use case, so now after your R&D phase comes the POC phase. The whole POC phase is where you convert your R&D notebooks into a whole deployable, usable, integratable service. So we basically need like a front-end interface where the users can communicate. This can be a chat client that you self-host, or this can be like integrated into WhatsApp, Teams, or any social media. So it depends on the requirement. But there's always going to be a UI interface where the users would communicate. So how the users would communicate with whatever information that's coming out of the UI, you need to have like a REST API on your service layer. So that is where you wrap around all of your orchestrate agents, the RAG agent that you built, the API agents that you built, or the generic agents, whatever you build. You need to wrap all of these as a exposable service that can be exposed as a REST API that where your front ends or wherever you want can talk to.
We'll spend 500.
All right. So like we mentioned, like Yasin also mentioned, basically we need to have like a travel content, right? And we decided that we are going to go with a RAG agent. So in a deployed application, we need to have a mechanism where we can update this information or update your information into a vector store. You can't simply just manually run a notebook always. You need to have a scalable and a automated flow that you can do this. So for this use case, what we thought we can do is we run like a daily cron job where we do like web scraping, where we give the travel blog sites and it will scrape the content out of it. It will do the automatic chunking and it will index or save this chunked information into your vector store. So for my implementation, I have used ChromaDB. So ChromaDB is my vector store and my RAG agent would be using this ChromaDB vector store. And then we decided that we need to have a currency convert agent, a weather checker agent, and then there can be a normal agent to check events. But this part I've not implemented. I'll just show using these two parts. So these will be talking to these external APIs like exchange rate API and open weather API. So you can use these APIs also. This is free. I've on the use case document, I've added the links as well. You just need to create a token, and I think you have like 1,500 free requests. You can, when you're building your agent, also you can try it out. But when I'm building this service, I've not exactly gone with an API agent approach. So I've gone with a generic agent tool calling approach, just for you to learn about how tool calling works as well. Because I think there was a question about how we can build API agent. So I've gone with that approach, and basically there is a whole orchestrate agent which talks to each of these agents and give you a final answer. So I'll go to this one. So first, if you look at this, so I have a whole endpoint where I can see what type of agents that are there in my multi-agent system. So we can see that there is a whole weather agent that agent provides information, weather information and forecast, and we can see that it's using the weather API. So its capabilities are like fetching current weather, interpreting weather data, recommending local activities, suggestions, providing insights, things like that. Then we have a travel budget agent. What the travel budget agent does is it calls the currency rate API to convert your API, but mainly the budget agent's prompt revolves around like giving you, based on your budgeting requirements, giving you insights on what type of destinations you need to go, recommending affordable travel options, accommodation, estimation daily costs, and it's sort of like a financial planner for you. This is another specialization. And then we have the whole travel rag agent, which gives you information and recommendations out of like brochures, websites, blogs, and things like that. So like I said, this whole cron job trigger, we need to have an API to add this data into, scrape this data and add this data into your vector store. So the endpoint looks simply like this. So there is a whole scrape and store, like an HTTP endpoint. So you give like the website URL. So I used Lonely Planet. And then the scraping method that has been used is trifacture. I can't say that name. So there's a library. So what it does is this Python library, it doesn't take like footers, headers, and like junk information on your HTML. It only takes the content information. So that's why I used that scraping method. You can use other scraping methods like Beautiful Soup, and then like Yasinda mentioned, there are AI web crawling and AI web scraping. Then you have things like Selenium, where you install like a web browser, and on Selenium you can web scrape. So you can definitely use that. And then out of the R&D that you do, you understand like what type of chunk sizes, the chunk overlap, the chunking strategy that you want to use when you're storing this information. So this is how my ChromaDB looks like. So basically I have like 47 chunks, and I have totally added about 3 websites, and each of these chunks, so these are the websites that has been added into this vector store, along with the, so I mainly store like the domain where the data was taken. I give like a title to these vector embeddings, and then I store like the text, like the chunk text, and then the embeddings also on my Pinecone DB. So my Pinecone would look like, there'll be like a title, the domain name, then there'll be something called the raw text chunks, and then there'll be the embeddings. So when my rag agent is invoked, what happens is, so this is like a basic rag agent. You give like a prompt, and like I just give like, when is the best time to visit Sri Lanka, and I say get the top 5 results. So what it does is, it goes into my ChromaDB, and then what it does is it converts this question into a numerical representation, and then it does a whole matching search, and then it gets the top 5 similarity score information out of it. So you see, like all of this information comes out of the API. So this is the whole explainable AI part, where you just don't see the answer, you also see the explainability on from which chunks that this information was extracted out. So this is the final answer that you get out of the LLM, but as well as you see the chunks that was used to generate this answer, along with the similarity scores and the source URLs. So that's the what do you call rag agent. Then we have like the weather agent. So on the weather agent, if I just simply use this weather agent alone, like what if I type like what's the weather like in December on this, so what it will do is it will call this weather API. So this is the whole data that we get from the weather API. This data is then converted into this humanized answer. So we see like now we get this sort of descriptive answer because I have given a base prompt for this weather agent. I'll show those base prompts where it is safe and all of that. But because of this base prompt, I on my base prompt, I've said like, give me insights on this weather and recommendations on detailed recommendations as a travel agent. That's why I get a descriptive answer like this. But simply, this is where we are doing a tool call using this API, and then we get the information. Then we have the whole travel budget agent, the other agent that we're using. So like I said, we are using 3 agents and then the orchestrator. Here, if you type like I have a budget of $300, how much can I expect to spend on accommodation and food? This uses this currency converter to convert these $3,000 into LKR. So it got like on Sunday, July, at this time, this is the real-time currency rate. And then it generates this final answer, because here again, I have given a base prompt to give like a whole budget friendly like a financial advisor to give the answer. So it gives like this is the budget. Based on this, you can use this type of accommodations per night. Eat in local places, which would cost around this. So it gives like a whole recommendation and insights. Yeah, so this is the user prompt. You can see this is my base prompt that I've given. So you're a smart, friendly, financial savvy AI travel agent, which can give travel recommendations on a budget that is provided. Use the currency convert API to get the local amounts, and it gives the answer. So now that we know the three main agents that we have, let's see how the orchestrator works. So this is my orchestrator. So I say like I want to visit Mirisa for 10 days. What are the weather conditions, estimated cost, must-see attraction? So you see that this is the comprehensive travel brand for your 10-day trip to Mirisa. So it took the current conditions in Mirisa North using the weather API. Says that it's about 25 degrees right now, but it feels like 28 degrees due to humidity of 86%. So there is a chance of patchy rain, and the wind is about 23 kilometers per hour. So it gives the whole information from the weather agent and the general climate. Then it also gives in like the from your travel budget agent. It says like what to pack, so light breathable clothing and all comes again from the weather agent, because I've said based on your weather, give me like give recommendations on clothing to use. So it says like what to pack, light breathable clothing due to humidity, a rain jacket. And then from your budget agent, it says like use like budget guest house, hostels. It costs around this. This is the food that it takes. This is the food amount. Then take exchange. It says like it's cash friendly. So use cash is preferred in Mirisa, because when you use cash versus card, so it gives in detail information like this. And then it gives me the attractions, because I'm asking about the attractions. It says like go to Coconut Tree Hill, travel by bus. It gives the budget friendly options along with going into your attraction. So it gives you like a comprehensive guide on what to do. So it all depends on the prompt that you set. I've set a very simple prompt, but if you set a very comprehensive prompt, you get a very comprehensive answer. So you see like again the explainable AI part here. You see like which agents were executed and what each of these agents answers were taken. So as Yasin said, what happens is we take each of these agents answers and we aggregate these answers and give one final answer. So you see like these three agents were executed, and from these three agents, these answers were generated, and using these answers, the final answer was generated. So this is how your multi-agent system works. And we also need now when it comes into like on the R&D phase, we know which agents we need to use and all of that. But on the POC phase comes in all of these features aspect as well. So as I mentioned before, there's one feature where we need to have a chat history maintained, right? So basically, if you want to use chat history, so I'm using a very simple approach. So that there can be complex approaches where you save this chat history on like on a cache DB or a persistent storage, and you fetch those information, or you can like have like a what do you call, like a Kafka stream where every time it's updated to push those changes, things like that. But I'm just keeping it in memory and I'm taking. So what happens here is for this it's a file. So you see that there's a session ID generated, a custom session ID that is being generated for each question, right? So you can simply pass in this session ID, and then if you say like which is the closest. So talking about until this phase, I'll just give you a few other things as well. So response time is really important when you come into production level application. That's why, like Yasin mentioned, we need to talk about this whole parallel executions. We need to see which type of agents we select, if we are selecting the right agents. If like an unwanted agent is selected by the orchestrator when it is not required, that might be an undue cost on like performance, as well as on that there might be a financial monetary implication as well. So those type of optimizations we need to do when we come into this POC and MVP stages. So those are the main things that will be optimized here. So like I said, visit which is closest. Yeah, I think this can't answer it because it doesn't have Google Maps. But so what happens here is it will take what it does is so you can see like the chat history that is here. So what it does is it takes this previous information and it uses this information to optimize this query to include this chat conversation. So what we do is like this question would be optimized to think like among the locations in Mirisa, which is among the locations which is closest to Mirisa, something like that. So that's the essential idea of chat history maintenance and conversation history maintenance. So in this question, that is what happened. So what I said was the previous question was where do I need to go, and it said Mirisa, and then what clothes should I take? So then it understood like planning a trip to Mirisa, Sri Lanka in December, which no, this is the chat history. I don't think I can show the optimized query here, but the optimized query will be like planning a sorry, what clothes should I take to Mirisa? So that's why it has taken the Mirisa context and given this answer. So then I'll talk to you about how this this thing works. So like I said, our configurations need to be separated out from the code. So it's better or it's good if you can persist your configurations on a DB. But for this demo, I have not persisted in a DB. Instead, what I've done is I have something called a config.json, which basically have all of the prompts, the model configurations for each of these agents. So what I did was I have some endpoints that I have defined to update this config.json as well. So I can at any time on this travel agent, I can update the prompt. I can just simply change the prompt. I can simply change the model. So that type of dynamic configurations are required when you after you host this, because you can't do always so changing. So Yasin, I think Yasin would mention changing prompts is almost an hourly thing or a daily thing. There'll be always an instance where you need to change prompts. So you can't do code changes and deploy hourly or daily. So you need to have a mechanism to simply update them without affecting your production applications. That's why we have these separated. So you can simply using an endpoint, you can update them. Then, so like I said, I have all of the prompts and models here. So then I have a whole service. So like I said, I'm using tools. So I've defined these API tools. So I have this web API tool which uses this web API URL. Ideally, this API configuration also should be here. So this is not the proper way to have it. And then you can I have the web API code. So what happens in this is the function which simply calls this web API. So you have just like a HTTP client initialized, and you just call the API with the respective payload. So the difference where you need to use an API agent and a tool is this tool, I know the payload and I know what changes in the payload. So I just know that I need to just add the location or append the location. So that's why I've gone with a tool approach where I have defined the other things as, because other things are going to be static as static data. And I define like the location to be appended on this tool. But in case there is the whole payload structure is changing, then you would need to go into an API agent approach like Yasin has done on his R&D. So this is one API. This is one way you can do tool calling. Then there's this whole currency API that I've defined. So this exchange rate API, again, this is the API, and it simply does again the HTTP call to get the API answers. So finally, you need to define the tools that you have. So these are the tools that I have. Like I have a exchange rate API, and these are the available tools that are there. Then what I do is on my generic agent, I take my tools, And then I instruct. So this is the whole part where we take configurations, where we load the prompts from our config.json. Then this is the whole context awareness that I mentioned. So on context awareness, what we do is we have a base prompt that we've defined. On this base prompt, what we say is when a question comes, take the chat history context and change the query, optimize the query, including the chat history context. So this is the whole multimedia that's not required. Let me show you. Tools. Just give me a second. Yeah, so this is the whole, this is the function where I process the query. And sorry, I'm looking at the wrong one. Yeah. Yeah, so here you see like this is the process tool querying API, like the function. So what I do here is basically I have the function declarations. So I have the tool function declarations that I mentioned in this generic tools. So this comes in here. And then what happens is on the LLM, I've said like if these type of questions come, I'll just show you. These are the functions. So I say like I'll show the weather API. Yeah, so here you see like this is like this basically says like when to use your tool. So if these type of information comes into your LLM, considering these intents, it will pick that it needs to use a tool and it will call the tool. So that's where this tool calling happens here. So it gets the available tools and it gets the parameters and the requirements to invoke this tool. If these requirements are fulfilled, then this tool would be invoked. Once this code is shared, you can probably go and look at the prompt. I can't simply able to find the proper prompt here. But essentially what here says is like this is gets the current time or gets the current date. So if you get like so this function accepts like string parameters. So you need an object parameters where you need to give the time zone as a string. So then the LLM knows to create this payload and call that tool. So that's where the tool calling happens here. Then I'll show the multi-agent. So one important thing is now I done this on Fast API. So to expose it as a service. So it's important that you define each of these agents so that it can be individually called as well as called in a multi-agent system. So basically, my multi-agent query accepts like a user prompt, a question, the session ID for chat history, and then the context window size and things like that. These are all passed in from the configurations and things that need to be accepted from the client, like things like now the user prompt and all, it's passed from the configuration. Things that need to be expect, we need to get from the client, like the question, session ID, things like that. Then we need to expect it in the payload as compulsory parameters. The rest of the things can be optional parameters where we do it on the backend itself. I'll just show you the multi-agent service. So on the multi-agent service, what happens is we give like, first what we do is I said we do intent matching, right? So for the question, we first extract the intent. That's the function. Yeah, so what we do is we first match the intent, and based on this intent only we first take the intents out, we extract the intents out. From the intents, then we identify which agents need to be selected. So then it will, for each agent, we've said like, these are the intents these support, these are the capabilities it supports. So based on the intents, what we ask the LLM to do is map the agents that are required, because on the agents we give like the intents and then the capabilities it supports. After it picks the agents, what we do is we simply execute those agents using like, since I define these agents separately, we just simply pass in the payload that needs to be used to execute this agent, and we execute them. After we execute these agents, what we do is we take the answers of each of these agents, then aggregate it and pass it to an LLM again, and from that LLM we finally generate the answer. So this is what happens here. But now let's see why we need to do this. So basically, why we need to separate this out is there might be instances where you don't need multi-agent systems always. So then you need a mechanism to invoke each of these agents separately. Let's say we have a new use case that comes where that use case is about getting weather only. If you need to get weather only, then you invoke that agent separately. So you need to separate it out, where it's like a micro agent service architecture, like not microservices, but you have micro agents that can execute individually. Then you have the whole orchestrate agent. Then you need to think about like response times. Then you need to think about what type of things you can parallelize. For an example, when you are like fetching data out of your vector stores, if you can fetch all of the similarity set chunks, like let's say I have 5 chunks, if all of the 5 chunks can be parallelly fetched, those type of parallelizations you can have. Then executing agents. Now here, if you take this, so if you get this as well. So basically, this will show your execution plans. So if you're executing it sequentially, then one after one agent only things are getting executed, then it takes time. So if there are instances, if one agent's information does not affect the other agent, then you can simply parallelly execute those agents. Then the other thing is, it's important that you cache certain things like prompts and all. If you need to always fetch, that is also an additional hop. So you can cache those things and keep those things. So those kind of optimizations you decide when you're doing your POC and when it comes to MVP stage. So I think Janidu would talk further on it. But those are the things that you can optimize when you build this out as a service. So for all of your questions, now you have these services, you have these endpoints, you simply go and host these separately. And then you simply expose these endpoints into your client applications, and the client applications can start consuming it. So I'll share this code as well so that you all can try this out. But that's what I have for this. So I think now Janidu would talk about like going into the next steps, like bringing in compliance, what type of security we need, how we can evaluate. Now these answers, we now finally got to a stage we can get an answer. But is this answer right? We need to evaluate if this answer is right. So that part. Then now this response time, we think it's good, but we need to go through a whole performance test phase and see how we can do optimization. So it's an iterative thing. It's a whole iterative continuous development thing. So where after you do your monitoring, then it will come back to again your R&D stage. It will come back to your development POC MVP stage, and it's a continuous cycle that you'll do. So over to you, Janidu.
Yeah, thanks, Pura. I will share my screen. Can you see my screen?
Yes.
Yeah. Nice. Just open it. So here, as Pura mentioned, once an agent is developed and is configured,
we need to see if the agent is acting as we want it to work. So there, what we do is we evaluate the agent with a certain number of criteria. So first, what we do is we check for its factual correctness. So we check if the answers given out by the agent is actually the answers that we want. And then we also check for the task alignment to see if the agent has followed the process the developer has defined the agent to do. And then another thing that we look for when evaluating the agents are if to see if the agents follow a safe, ethical, and authorized approach when generating answers. And other than that, we also have the reasoning where we get the explainability and then the accountability, and then the cost and latency where we measure the budgets and the efficiency of the agent. So these criterias matter the most in sensitive fields where medical, financial, and other sensitive topics are discussed. So when giving out answers, it might have severe repercussions if the agent is not configured as the if it is not configured the way we want it to be configured. So now let's see how we could evaluate these AI agents. So the evaluation of AI agents could be done in three approaches. So one is the automated evaluation approach. Another one is the human in the loop approach, and then we also have common matrices to evaluate the agents. So here I'll just skim through a few of the evaluations. So heuristics is where we check the format of the agent response that generates. So if you want to see if there is if you want to see regular expressions that we expect in the answer of the agent, or if you want to see if the output that we get is a JSON. So those things are done by heuristics. And then LLM as a judge is done by evaluation of the agent answer by another LLM. So there, what we do is we define a certain number of criteria that we check for in the agent answer, and then we send the prompt and the user query into the agent, and then we generate the evaluation out of that. And going into some human in the loop evaluations, we also have a rubric grading where we can define a set of matrices which are chosen for the use case of the agent. We also have A/B testing where we compare multiple prompts, and then we come up with the prompt which fits the use case to the best of his ability. And then in some of the common matrices, we have the latency, which we check
Jonathan,
the time.
sorry. Jonathan, could you go into presenter mode?
Right.
Because yeah, I think we're seeing the whole thing.
Right. Can you see the screen now?
Now it's showing the yes, perfect, nice.
Yeah. So as I was saying, the common matrices are matrices where we check for the latency, grounding where especially we check the sources we check the answers with the sources that's generated by the RAG agents. So those kind of things are the matrices that we use to evaluate the AI agents. So for these evaluations, there are multiple frameworks and libraries that are currently existing in the workplace right now. So here we have Promptfoo, Langsmith, Ragas, Helm. So those kind of frameworks and libraries can be used to do agent evaluation. And then at the end of these slides, we will go into a live session where we see how agent answers are evaluated with Promptfoo. Yeah. So as Pura said, evaluation is not just done in one stage. it is a continuous cycle in the agent life cycle. So first, with the R&D, in the R&D phase, what we do is we manually check for the we manually check requirements that we need in the answer that is generated by the agent. And also we do A/B testings of prompts where we compare multiple prompts with each other, and then get the most suitable prompt for a use case. And going into POC, we start automating evaluation here. So we evaluate error handling, we check for edge cases, and then we also we write functional validations for tool calls as well here. And going into the MVP stage, here what we do is we automate the prompt testing by integrating it with a CI/CD pipeline, and then we also try to get real-time feedback where we can improve the prompts regularly with the feedback that we get. And finally, going into a production. So with evaluation, one of the main goals is for the agent to mature from a POC MVP level to a prod level. So that's where we get the end results of the use case that we have implemented for the agent. So here what we do is we reevaluate the configurations, model configurations, prompts, and then other configurations that are set to the agent. And also we use monitoring to continuously see what are the most common questions asked, how the agent responds to those questions. So these kind of things is done by continuous monitoring in the system. So I'll just show one of the monitoring scenarios that we came up with in one of our use cases. So here, this is a density based clustering that we have done. So here, as you can see, we cluster the questions according to the similarities that they have. So by this, we can see if so especially in RAG agents where we upload documents as the source reference, we can see if the questions that are asked for the questions that are asked, the reference sources are there in the vector. So or else, if not, we could upload those sources so that the agent could answer these questions in the for the user to use later on. And then going back to the slides. I'll also take you through how PromptFoo works. So here, PromptFoo is a library where we use it for both evaluation and then LLM security as well. So this here, what we have done is we have installed the library, and then we have hosted this on EC2. So you can do this as well. And then once this is installed, we can add a prompt, or we can add a couple of prompts where we have the agent prompt defined in the agent configurations. So this is the prompt that we'll be testing out if we testing out for the evaluation. And then once we have defined the prompt, we could specify the models that we plan on comparing the prompt and the answers. So here we have used the Gemini models with Flash and Pro. So once we get the evaluation, we can compare what model suits our use case the best. And then after that, so these tests are mainly done because so we had a use case where for every prompt change that we did, we had to do, I think we had to do about 100 tests to check if the answers that we get is is valid, is in the valid format. So here, since the manual process is very tedious, what we did was we looked into a framework where we could automate this test. So Prompt4 allows us to predefine tests where we can define the inputs, the prompts, and then once there is a change done in the prompt, we could update the prompt and then run the test cases and see if the results that we get are the results that we expected from the agent. So here, when defining the test cases, we can add multiple variables. So variables are the dynamic values that will be input into the agent query, and then once that is done, we could define the types of assertions that we need to do. So we could say that we need the final answer to contain the word destination. We want the final answer of the agent to contain the word why. And likewise, we could define a certain number of criteria and then the value of those criteria. And then we also have this criteria called LLM rubric, where this is a use case where we use an LLM as judge. So here, what we do is we send the answer to another LLM and then ask that LLM to evaluate the answer according to the certain a set of criteria that we have set. So these are the criteria that we have set for that evaluation, and then we have also specified the scoring value where the agent could give a score according to the answer that's provided by the model. So likewise, I've defined 9 tests that we'll be testing out. So for this, when we run the command npx prompt for evaluation, the evaluation will start. It will take some time. So we have 36 test cases which are running in 9 different inputs. Yeah, so as you can see, we have 30 succeeded test cases and 6 failed test cases. So if you want to see this in a browser, we could just type in prompt for view. And then we could get this into a browser mode. Yeah. So this is the test cases that are generated from prompt4. So these are the 4 columns that we have for the 4 models that we are using. So here, as you can see, in each of the agents, we can see the past state with this dashboard. We can also compare 2 different prompts. So we can select what prompts that we need to use. So it will show how the prompts have performed by comparing itself with each other. And then here in the table, we have the use cases that we have defined. So in the first column, we have the inputs, the input value, which is the user query. And then here we have the outputs for each of the models that we have defined. And then here in this we get the number of tokens that have been used, the time that has taken for the age for the model to respond to that specific prompt and user query. So as you can see, the Flash model, which primarily focuses on speed, has only just taken 29 milliseconds. But then with Pro models, it has taken about 342 milliseconds. So that's a very big time compared when you apply it into a real world use case where we get thousands of user queries every minute. So as you can see, we can see what tests have passed, and then we can also see what tests have failed. So here once we see a failing test, we could go into this test, and then we can see why that test case has failed, and then we could one thing is we could check if that's a edge case, and if it is not, we could go into the prompt and then make the change, and then we could run the test again. So that's how we can get the evaluations from the YAML file. But then we can also create evaluations from the from the interface itself. So here we can select the models that we want. So if we are using let's say that we use a model with the open API. So for that we need to have an open API key which is stored in order for us to get results from the evaluation. And then we can also define the prompt that we are going to test out. We can define the test cases that we intend on testing the agent response. So when we add a use case, we have assertions. We have there are hundreds of assertions that you can use, along with other matrices such as blue and raw. And then we also have perplexity, which is primarily used on RAG agents. So all of these assertions could be used to evaluate and test out the agent response and the prompt as well. So that's it about prompt. Another thing is you can also see what the previous prompts that you have defined here, and then the previous test cases that you have run, and then also you can see the inputs that have been defined for each of the test cases. That's it about prompt. That's a bit of prompt. Now going back to the presentation, I'll take you through some of the vulnerabilities and risk that organizations face when it comes to LLM-based agents. So here, I'll go to presentation. Here, when it comes to threats and vulnerabilities, one of the most common vulnerabilities that we have is prompt injection. So I know like 90% of the people who have worked with LLMs like ChatGPT have at least tried out entering a prompt such as ignore all the instructions that I have provided, that has been provided for you, and then do this thing and do that thing. So this is an example of prompt injection. So the systems need to be guardrailed in order for the prompt to not execute, and then for the prompt to expose the configurations in the system. So likewise, we also have indirect prompt injections where sometimes when we upload a file, a statement is there where we use that statement to inject a prompt into the LLM. Likewise, we also have data leakages, tool misuses, hallucination attacks, context exploitation, which all can impact the answers generated by the agent, and then can manipulate the outcome of the system. So the risks which are involved in with these vulnerabilities and threats are the confidentiality breach of systems, integrity violation of systems, the availability risk. So most of these risks might be very severe when it comes to real world applications and large scale enterprises where every time there are users using the systems, and also when it comes to non-compliance and loss of auditability, we look into the aspects where we could improve prompt security with by mitigating these circumstances. So when looking into mitigation strategies mm, to get rid of prompt injections, we could use prompt strategies such as prompt sanitization. So likewise, we could also use structure prompting, like Yasinda mentioned. We could have frameworks which the developers can define in each and every role, instruction, and guardrail. So those things, it is the responsibility of the developer to look into these aspects and then see how they can mitigate these strategies. And also, when it comes to tool and action control, we can allow the least privilege to tools and tool accesses, and then we can also secure sandboxing, where we do not expose the agent unless the environment is secure. We can also, when exposing tokens, what we can do is we can make these tokens into time-based tokens, and then moving into runtime and monitoring. What we can do is we can check, we can backtrack where. So let's say that the prompt has been changed and then the system is not working according to plan. So what we can do there is we can backtrack and see who has made this action and what action has been done. So all of these vulnerabilities and risks could be mitigated through safe and secure practices, such as these mentioned in the slides. So that's about prompt security and evaluation. Pura. So now I'll hand over the presentation to Pura to continue with the presentation. Thank you.
Yeah, I think that concludes what we need to say. So I'll just quickly show you one final diagram and let's end it off. Nothing much. Yeah. So basically on our workflow, like what we understood throughout the whole flow was first we need someone to do our configurations. So these people need to be authenticated. We need to separate out our configurations. Then we have the whole request flow that comes in from a chat client. Then we need to understand if we need to do things like data masking. These are optional things that we need to do. Then we need to understand if we need to talk to agent tools and things like that. What type of agents need to be talked to. Then the final response when it's generated. We need to understand if these responses need a human in the loop to verify it. This is also optional. Then the whole evaluation part. Once it comes back again, if there are confidential information coming out, we need to mask those data. This is also optional. And finally, we give the answer. So this is the final flow that happens in an enterprise system that we talked about. And I think we can go into questions and answers. So the whole, I hope you all understood certain things. And I see that there are a bunch of questions. Sorry, my camera is also not on.
Okay.
Yeah, so that's all.
Okay, so now it's time for the Q&A session. So please share your questions via Slido, and the link has been provided in the Zoom chat. And our speakers will be more than happy to answer them.
So a few questions. Let's start with just take random one. There's one that said, can
No.
you speak a bit about, yeah, sorry. Yeah.
Okay.
Medan, do you
So
want
the
to
very
go?
first question will be,
Oh,
can
okay.
we host? Yeah. Okay, so can you speak a bit about the XAI that you're using? Is it COT? The very first question.
Yeah, so great question. I think personally, at least what I feel is LLMs are at least notoriously, they are sort of a black box. Because the way it works is it's not like a traditional data science algorithm where you know exactly the math that goes behind it, and then you're able to statistically get the exact same response each time. Even if you were to set the seed, even if you were to set the exact same prompt, there's a chance that it might give you a different answer. And most of the time, that's exactly what happens. So to answer your question, there have been a lot of advancements going towards where people are trying to come up with explainable AI for LLM. So one thing to answer your first question, is it chain of thought? That is one way of explaining how your model came to a particular output. And then even the stuff we showed today, the stuff where Purnima showed where we show the orchestrated agents that are getting picked up, that's another way to show explainability, because you now bring it down to a case where instead of saying, okay, the LLM gave this output, you're now stating that you're coming one level lower, where now you're saying this output came from this particular agent. So in a way, that is explainability. But then if you want to know specifically what sort of algorithms can be used for explainable AI when it comes to LLMs, the best you can do is to visualize which attention layers got triggered for a particular user query. And to do that, there are visualization algorithms like BERT-TWIST. That's at least the one I'm aware of. It has a lot of recognition. What happens is when you ask a question, BERT-TWIST will show you what sort of attention layers got triggered, and based on that, why you got the output you got. So that's as far as XAI would go. But if it's traditional, there's a whole bunch you can look up, such as SHAP and Line. But yeah, hope that answers your question.
Okay, so the next question will be, where can we host agent AI?
Yeah, I'll take that up. So I think I explained this on while I was doing the demo as well. So we don't host an agent. So there's how can I say it? An agent is what's the word I'm looking for? It's an abstract thing. We don't have an agent running, but we have a service wrapped around an agent running. So where we have a bunch of functions which is an agent essentially. So we host the service. So we can host it wherever you want. It can be on a Kubernetes cluster, wherever. It can be on Fargate. It can be on serverless, or in like EC2 in a server, wherever you want. But whatever like agent, what you mean by an agent needs to be wrapped by a service that the agent can communicate with. So an agent is a bunch of functions that's an LLM call, but it needs to be wrapped with a service. So that service is what we host. So it can be anywhere you want. It can be, yeah.
Okay, so the next question is, Gemini Flash, are their APIs free? If not, can you list some that are free and good for experimental purposes?
Gemini
Honestly,
Flash.
it's so if you really want to use Gemini, you can get a free account, which has a few credits for, I think, for around 3 months. But to answer your second question, are there, I mean, can you list some that are free? Honestly, everything on Hugging Face. You can just go to Hugging Face. It's a library built for people like this. So it's basically, once you go in, you'll find a set of models, a set of LLMs for different types of stuff. You can go there, just filter by free. You'll get a whole bunch of stuff. Just keep in mind, because every time a new LLM comes out, something that used to be non-free back then will always be free. There's a whole bunch you can get from there. I'll just send the link, I guess. But
yeah, and also you can host your own SLMs like Olama or things like that, and then you can use them locally as well.
Okay, and the other question is DB call versus DB agent. I think it is sort of like a comparison.
Yeah, so I'll start and Yasin can add. So DB agent is where you have the whole natural language text like conversion into SQL or a query, a DB query. So when you have a DB call, basically you have to define the query that you need to communicate with your DB, right? It might be on a repository layer. using like libraries or JPA or like things like that, like SQLME or something. But essentially, you need to talk to a DB using a query. But that query generation part, when you need to convert it from natural language text to the query, that's where the DB agent comes in. So where you have a natural language text, you passed into LLM and you convert it into query. Yasin, do you want to add anything?
No problem. Then that's perfect.
Okay, and the next one is how to do CI or CD in agentic app, any framework.
Yeah, I'll start and then Janitu or Yasin can add. So, or Janit, you want to give an answer?
Go ahead, Pura. I'll take over.
Okay, so basically, it can be, it depends on the framework that you host, like your GC, whatever resources that you host your application on. Let's say it's going to be like a serverless thing. You can use basically like Jenkins pipelines or things like that. Let's say you want to host it on Kubernetes, then you have to go with something like Argo CD and Harbor and Conco. So ideally, what happens is your app needs to be Dockerized. So one thing is you can containerize your application. So and these containers can be hosted somewhere. But if you don't want to containerize your application, then you'll have to go with an approach like build packs or where you use build packs to build your application. But the easiest approach to do it is containerizing your applications. And there are frameworks like Concos, Argo CD, Jenkins that you can use to do.
Okay, and the next one is the orchestration agent an LLM?
Chandra, do you want to take this? Or?
Yeah, orchestrate agents is also an LLM. So what we do with the orchestrator is we tell the orchestrator on what steps that the orchestrator needs to do in order for it to get an answer from a specialized agent. So that's also an agent where we set the models, where we set the prompts, and then we also have the reasoning part where an orchestrator can reason and see from which agent the answer that it gets is the answer that it can get is the most relevant answer. So let's say that we have two agents, a DB agent and an API agent. So the orchestrator can reason between the two agents and then see what answer you get two answers from both those agents. So the orchestrator can reason and see what answer fits the most to the user query that's given to the orchestrator, and then after that it can give out the response as expected.
Okay, cool. And the next one is, can you speak a bit about RAG evaluation frameworks?
Yeah, so going back to evaluation frameworks, there are a couple of frameworks that we can use. So one is Promfu that I just demoed, and then we also have Regas. We also have Helms. So so most of them are open source frameworks that are already existing and libraries. So with Promfu, what I did was I just installed it as package, and then we hosted it on EC2. And then once you have a API key or credentials for a service account, we uh, we can go ahead with the prompt testing and evaluation, and also we could use those frameworks for test security purposes as well. Pura and Yasinda can add on to it.
Yeah, so for security, we have things like Lakera AI, and there are a bunch of things that we are also analyzing. So there are a lot of so there's another thing called I can't remember the name. But there are frameworks out there. Basically, even PromptFu and things like that can do red teaming and things like that. Another one that added is DP well, where it can evaluate your orchestrator as well, how your orchestrator is thinking. So y'all can test them out as well. Yeah.
And also, there is one person who missed the modern XAI recommendation from Mr.
Yeah,
Yacinder.
I've shared that on the chat. So it's called BERT. That's a visualization. But
Oh,
pretty sure the stuff that comes out like every single day. So we could also do like a search there. But BERT is really good. It's very well known across the industry.
okay, and the next question is, when we run cron jobs every day, our vector database size will increase. That will directly affect the RAG agent's efficiency. How can we manage that?
Yeah, I think this this is one of those things where I feel like it's a trade-off. Even to start off with, these things are expensive. Vector DBs, I mean, not the ones we host on session, but the stuff where you keep, the stuff where you can, ingest into and just have it in the cloud. Those things can get expensive when you keep ingesting more and more stuff. And that also comes at the cost of extended retrieval time. But there are a few things you can do. But obviously, I think this thing is very use case specific. For example, there are algorithms where when you ingest into it, you can obviously do a similarity search then itself to see whether certain chunks are basically what you already have. And when you do that, you can obviously get rid of them then itself. And then there are retention policies you can attach. For example, let's say you have a single document that was added last month, and that's about some company policy, leave policy. And if only like one or two lines changed from that particular policy in the upcoming month, there's no need for you to have that new document existing as a separate set of chunks or a separate document. So something we do in our applications is we maintain versions where we identify the diff similar to GitHub, and we just ingest that new diff, or we just completely get rid of the previous version and we re-ingest that new version. So those things are, so like I said, these stuff are very preventative. It's not to say that they're also scaling, because if you think about it, vectors, they all have shards, and that's essentially where you get the ingestions coming out. So the way you configure those shards also matters. Ideally, if you have multiple different domains in a single vector store, you need to set them up in different shards, because that way you're not going to have one shard consisting of a huge set of contents coming from different types of multimedia. So again, more preventative than like the generic way we could scale certain things. But yeah, I think that's Purnima, Chandra, anything that's on it?
Yeah. So one thing, like Yasinda mentioned, so like there are two ways you can search vector store. One is brute force, where you simply go to every branch and see. Then you have a whole tree-based approach where you search. So like Yasinda mentioned, the shard size. So ultimately, your information is stored in a leaf. So if you have multiple leaves, and let's say you have so many branches and so many leaves, then you have to search across all of that and get any information. Or you can have one leaf with all of your data, so that the search time is fast. It goes to one layer and it gets. But then what happens is the information is not very specific. You have all the generalized information in one place. So your similarity search would change. Then another thing you can have is you can have mixed search. You don't only do similarity search, you do a keyword search. Then you identify to which branch you need to talk to. After you do the keyword search, then you do the similarity search. So there are options like that. Then that you can do. Then you can limit the number of branches you want to search if you want to only do a left branch search. So there are things that you can do to increase your retrieval, yeah, their algorithms.
Okay, due to the time constraints, we won't be able to answer to all of these questions. Are there any questions that all three of you that would like to answer, or the delegates could reach out to you directly through LinkedIn? What would be better?
I think we can go for like LinkedIn, and I think we can share our
Yep.
emails also here.
But I think there's one really good question on the top. Okay, I feel like most of these are great questions, but one specifically about going into production, a problem we face a lot. Just on the top, I saw something about how do you deal with longer runtimes, I think, something around that. I think that's a very good question people should probably talk a lot about. I can't find that. Yeah, this one, speed up response time. So I think at least something a lot of stakeholders lack awareness of is the fact that LLMs need time to generate their response. And obviously, if you have a workflow which uses a bunch of LLMs or even waits for a particular response from an agent, that's the time that's going to get added. So there are ways to deal with it. Like, for example, even in our particular cases, what we do is we try to, so there are straight out things you can do. Obviously, first thing you do is you swap it to an LLM that could spit it out faster. Like Janita showed, Flash models are always faster, but that comes at the trade-off of having less reasoning. But then it also comes to a point where you need to identify whether you can execute something in sequence or something in parallel. These are all things that can like shave off seconds from your final runtime. And there are also good UX practices that you can bring in just to make them wait a bit nicer rather than just having it all come together. So you can always stream and you can always consider options where without doing a sync call, you do an async call. So all this sort of stuff are very important going into production because this is something you can't really avoid. As you have more LLM calls, the time will take a while. So it's a matter of whether the time is worth waiting for the value we generate.
Okay, so I suppose that's it for the Q&A session. Please, delegates, if you have any questions, feel free to reach the speakers through the LinkedIn and ask your questions by yourselves. Okay, so a heartfelt thank you to Mr. Purnima Kahatapitiya, Mr. Yasinda Samaranaika, and Mr. Janidu Ratnaika for an insightful session. Your guidance on scalability and security has been invaluable. As a token of appreciation, we are now presenting this heartfelt digital token for your remarkable support during this session. Before we move forward, we would love to capture this moment with a quick photograph. I kindly request all of you to turn on the cameras so we can take the photograph together, and the background image is provided in the Zoom chat. And we will be taking the photograph within 2 to 3 minutes. Okay, due to time constraints, we will have to take it within a minute. If you guys could make it fast, we will be really appreciated. And after this session, we will be having the quiz, and 20 marks will be added to your final score. And you will have to stay after the photo as well. So please keep in touch with us. Okay, now we will be taking the photograph. Make sure to smile, please. Okay. Okay, one more. 3, 2, 1. Okay, thank you very much for your support. And now for a fun challenge is quiz time. So please note that again 20 marks will be added from this session's quiz. So make sure to give it your best shot. And the link for the quiz has been shared in the Zoom chat. And of course, when you join the quiz, please use the same about format for your display name, your team ID, and the underscore and your first name that you are provided when you registered. Please make sure to use the same above format. Otherwise, when we give the marks, it will be a problem. Please rename your names, your team ID underscore, then your first name. Here we have 45 players. We'll start the quiz in 1 minute. Make sure to rename your names for your team ID, then underscore, and then your first name. Okay, 9 players are there. Let's see, will it be 50? Okay, now let's start the quiz. The very first question is, what is a defining feature of agentic AI compared to traditional AI? Have the correct answer. So let's see the leaderboard. Okay, someone from team 112. What is a key benefit of agentic AI systems in enterprise workflows? answer. And let's see who is on top of the leaderboard. Okay, number 58. Okay. What analogy is used to describe orchestration in multi-edge systems? And I bet the leaderboard has been changed. Okay, cool. What is a key consideration during the use case identification phase? The answer? Okay, it has been changed. Why is a single API call preferred for a task like weather lookup? Okay, let's see whether Devin has secured the first place again from group 58. Seems like I am correct. Interesting. And the next question is, which feature is not a desired feature for AI agents in the planning phase? We have the answer, and the leaderboard is now presenting. Okay, it changed. What architectural consideration is shared between AI agents and full stack systems? Time is up, and I suppose it was Dinal last time. Let's see who is now. Again, Dinal. Okay. And the next question is, what is a common metric used to evaluate AI agents? See whether Dinali is still in the first place. Okay, good. What is a major security risk mentioned for AI agents? Let's see the leaderboard. Still Vinal. And the last question is
Still,
double points. Used to secure input-output in AI agents. Okay, let's see who are the winners. The third place goes to... okay. The winner is... Okay, Samindu, congratulations. Randita, congratulations. And then the second place is Vinal from group 130. Okay, thank you very much for your participation in quiz. And that's it for the session 3. Thank you all for your energy and curiosity. And we are excited to share that the AI Agent Challenge will be released by next week. So get ready to showcase your creativity and skills. Thank you very much for joining and have a nice evening.